tên các bạn, tên đề tài các bạn là Research Implementation and Application of Coordinate Industrial Camera for Manufacturing Automation System. Sinh viên thực hiện là sinh viên Trần Như Kiều Anh, mã số sinh viên 171460049. Giáo viên hướng dẫn là thầy thạc sĩ Lê Tấn Cường. Mời em.
Let's open your microphone. Let's open your microphone.
Okay, sorry. Em còn có thấy còn xe không vậy mọi người? Yes, I will start it. And good morning, all account teachers. Today's after hard working being conducted by Mr. Lê Tấn Cường, and me staying here to show you my final thesis inside on my project, research, implementation, and application of a coordinate industrial camera for manufacturing automation system. And my project has been including 6 steps to the process. The firstly is the introduction, the secondly is the literature review, and the next part is design, building model, and equipment. And then I will experiment with design and analysis. And the last step is to make conclusion and recommendation on my topic of the thesis. And for the introduction, where I say my purpose, reason to do this topic, and look on what I prepare for my the main session of my project. And my major in mechatronics engineering, so I decided to find out and through the projects, including automation components that will fit in with the knowledge I have learned and cultivated during the past times. And in this project, I using a camera of coordinates and design a classification models with belt conveyor and turntable. In addition, it can be seen that the application of the cameras for manufacturing automation system is very developing in the world today. Besides that, this topic is still new. And here, talk about the contents of the research projects. I using the reticle method to research and parallel to the model, to building the models with cameras. Today, and there are many types of coordinate cameras, but can choose internal companies support me of the coordinate inside 511001 series. Therefore, I using this device to apply to my thesis. And to accomplish this project, I have prepared coordinate necessary research as well as the application and software that is provided by the manufacturers. And along with that is the application of relevant knowledge in my training program. And here is the photo of the coordinate inside 511001 device, which I will put to you for my project. And here you can see some application of camera in industrial. And next, I'm gonna design an implementation for machine system. And about the requirement of the system, they are input conveyors, output conveyors, a turntable, and frame machine with camera placement. And since that I have a sketch, a drawing, and then I will design 3D model. And you can see on the right hand of the 3D model, here is my already accomplished models has on required component. And in addition, design of electrical control system play an important role. And the electrical control system including here is the central processor units, some sensors, and HMI, easy motors, web motor, and drivers. And the following that is the details connection diagram in my projects from power supply to circuits, diagram of the input signals, microcontrollers. And here in my electric box, and beside us, here is the ICVU, and the central processor units of Inguno company products. And after the mechanical and electrical parts were assembled and connected, so I got the complete model as follows. And here is also the photo and video about the complete models. And now I will show you an operation video of the machine system. And my products were made 3 months ago, but due to the influence of COVID-19, so the models is still remaining in the companies. And next, I will talk about the control programming system. And since that I have some flowcharts about operation process of the machine and operation process of the automation run modes. And tools and users could use control and setting parameters easier and more convenient. I have designed HMI interface by using VT Studio software and the slide on screen. So the setting interface that have been designed with specific parameters that can be adjusted. And my project is using Connect Inside 511001 series, which is models of ID, with the model for ID application, with the interface inside thorough and easy builders. Moreover, it is necessary to have a suitable software to configure cameras for the machine system, and specifically that's inside 5.8.1 firmware, I install and use until now. And here is configure step and how to use this firmware. And this is the connected step of camera and my machine system. And after that I setting parameters via software. And here is a short video of my different build during doing my projects. And I have run test many times to the design results.
Là phôi cấp vào là em sẽ để cái vị trí cái chai nó sẽ quay về một hướng để cho cái camera nó sẽ detect được cái mã vạch của mình.
Cái video này là trong quá trình em thực hiện đề tài nên là em có nói tiếng Việt thôi.
Đọc được mà. Bên này em sẽ xóa cái error not given trên này.
Can we skip this part?
Yes.
It's already in the video. So.
Yes. And here is as any other products, my project requires a list of metrics based on the needs of customers, which is so into table. And to meet the needs of customers, I give an important raise for S index after machine system working directly with the cameras for testing analysis. And here's a comparison table between important rate and successful rates of the specification. From tables, you can see all variables upper than 85%. For a general view about the successful rate, I have to bar charts. And beside that, the low successful rate of accuracy may a significant impact to the overall success of my projects. And on the other hand, which is the highly successful rate brought a huge impact to the projects. And there are some in my projects, there are some benefits of my projects. They are the time, high accuracy, but my projects have some limitation of the mechanical design. And the robustness of the coordinate inside 51101 depends on the surrounding natural condition, and the lies was of especially, and the thesis is theoretical, so it's necessary to build models to show learning and research process of the students. And the last thing, if I have more opportunities, I will improve and developing my topic better. And thank you for your watching.
Xin phép hội đồng đọc qua nhận xét của giáo viên phản biện ạ. Giáo viên phản biện về cái nhận xét của giáo viên phản biện về thứ nhất về kết cấu, cách thức trình bày đề án tốt nghiệp là báo cáo được trình bày theo yêu cầu của khoa. Tuy nhiên bản vẽ chi tiết sơ đồ mạch điện của hệ thống nên đóng thành file bản vẽ riêng, không nên bỏ vào báo cáo. Về nội dung đồ án trình bày một ứng dụng của hệ thống Smoothness Insight trong việc nhận dạng barcode của chai nước trên băng tải. Sinh viên tự thiết kế và gia công mô hình băng tải và lập trình điều khiển ứng dụng nhận được cung cấp bởi hãng Smoothness. Về kết quả đạt được, đã hoàn thành mô hình và chạy thử nghiệm. Về những thiếu sót tồn tại: thứ nhất, không có tập bản vẽ riêng. Thứ hai, bản vẽ không đạt yêu cầu. Thứ ba, phần tính toán thiết kế trình bày chưa logic. Về câu hỏi thì có 2 câu hỏi ạ. Sau đây cũng xin thể hiện câu hỏi trên cái, thầy xin up cái câu hỏi trên cái nhóm Zalo. Câu hỏi thứ nhất: khi lắp đặt camera cần thực hiện calibration hay không và vì sao? Câu hỏi thứ hai: tại sao không có hệ thống chiếu sáng hỗ trợ cho camera? Rồi, mời em.
I will answer the question. I think the calibration is necessary to adjust properly the accuracy and stability of the cameras while the system working because the calibration which will have to reduce and eliminate unnecessary deviations. Although inducement deviation cannot be completely eliminated, and it can be detected in time and correct through calibration. And since then, with the effect of the calibration bring to us, as well as the cost and risk. I mean, some problem of non-calibration, don't use calibration. I mean, the calibration when installing the cameras it really is necessary. And the second question, during the process of researching my topic, one of the rare challenges of using Vision Studio in general and industrial cameras to checking products in particular, that's the light. And because natural lighting or factory lighting are both extremely complicated, and that will damage the receive image, and more dangerous, it can make harm to my camera device. And however, the arrangements of the lighting system for the camera is also not optimal solution for the system. Instead, the camera can be assisted by a filter that is built into this device through the software. For example, a color filter to bring more visual contrast. And in addition, today there are some cameras equipped with infrared light or high performance machine vision software that can also regulate the light of this device. That's all.
Các thầy trong có câu hỏi gì cho đề tài này không dạ? Câu hỏi cũng như góp ý ạ.
I just have one comment on your report. At page 7 on your report, can you open the report?
Yes. Sao em không share được cái Word ta?
Em share nguyên màn hình thế.
Dạ.
Em share hết cái desktop của em á thì nó mới ra được. Hiện tại là chỉ có cửa sổ Explorer thôi.
Dạ thấy chưa?
Rồi em mở đi. Chưa thấy đâu em phải share hết cái desktop á. Cái này em đang share cái cửa sổ file thôi.
Dạ dạ.
Chưa được rồi. Ok, nếu mà em không mở được thì thầy nói thôi. On the page 7, the subsection 2.1.1, you said from the above velocity calculation. From the beginning to the page 7, there are no velocity calculation. So please fix this in your report. Okay. Did you understand? Because you said the subsection 2.1.1, theory of the machine and machine design.
Yes.
And the next sentence is from the above velocity calculation. There are no velocity calculation in this report, so I don't know what you refer to. You understand?
Yes.
And the reference is improperly cited. I don't know. You can scroll to the bottom of the report. I can see a lot of website. It's not properly cited. Okay, so please fix this.
Yes.
Thank you.
Yes. Thank you, teachers.
So I have some comment and a question for your thesis. Actually, this is a very simple topics. This is a very simple topics, but there are one student. So I think the content is proper. The main content focuses on the using camera to read the barcode. However, it has some also have some practical application for classifying the products and check expired products also. Question, what are advantages of using camera in comparison with the other sensor and or other devices? Okay, you can answer.
As I can say in the word today, Smoothness is the leaders of in the supply of the equipment related to vision system, and thank you, and my companies also support this device. I took advantage of it in my project, and this device is a model for ID application, risk barcode, risk test, but barcodes also play an important role now and before manufacturers want to bring products to the markets. And so I did research and select equipment for the subject.
So I think it's not a clear answer. It's not a clear answer. So you said that because this is device from your company or your support or the support from the other people. So I think it's not convinced me. So I'm asking you that question because there are many similar products. They have already commercialized. So that's why the people can use any sensors, can use other sensor, cheaper, and the technical is similar. So that's why I'm asking you, why do you use this camera for this application? But I think this answer is not convincing me. Okay. Okay. Continues the next question.
Okay, thanks, Prof. I think it's quite tough for her to handle the project alone. Right? Why don't you ask some of your friends to do the project with you? Okay, and I think the Cognac library is quite powerful. So you can use its library to add the application, for example, detect if the cap is still on the bottle or not. Or the label of the bottle is correct, or any problem with the label or the label of the bottle. I think much more convincing than the reading barcode, because reading barcode you can use other sensor like Prof. Tan said before. You know.
And how do you align the bottle to let the camera read the barcode?
It means that you reading the barcode online or offline. Online means that the bottle will keep moving. The camera process it online when it's still moving, or you stop the bottle and capture the image. And if you stop the bottle and capture the image, then how can you know the position of the bottle? What kind of sensor did you use?
Yes, risk barcode online. And the conveyors move working continuous, and when the portals and detect by sensors, and the conveyors will stop, and the my camera to can detect the barcodes.
But you have only one camera, so you can capture the image on only one side of the portal, right? So
Yes.
what happens if the barcode is not on that side?
Because wait a minute. Because I initially this research to make a filling and capping system, but because the workload of one student, and because of pandemic situation, so I couldn't do it in time, and if I given the opportunity, I will improve my products more fully.
So as I understand that, she put the bottles first in the conveyor belt. So after that, the barcode will forward to the camera. So the camera detect the bottle directly. So it means that the barcode of the bottle will directly forward to the camera. The direction is right. Okay.
Okay, any question? Any more questions? Okay, if there are no more questions, then we can move on to the next project, right? I think she quite confused now.
Nếu như hội đồng không còn vấn đề nữa thì đi qua cái đề tài tiếp theo ạ. Đề tài tiếp theo có tên là Research and Implementation of a Semi-Automatic Packaging System for Schneider Electric Manufacturing Vietnam using LabVIEW SUBH Communication Hub. Thì sinh viên thực hiện đề tài gồm có hai sinh viên. Sinh viên Vương Đạt Hưng, mã số sinh viên 171463031. Sinh viên Lê Đỗ Tuấn Phúc 171465054. Giáo viên hướng dẫn là cô thạc sĩ Phan Thị Thu Thủy. Mời các em báo cáo.
Okay. Hello everyone. My team would like to continue the report with research and implementation for a semi-automatic packaging system for Schneider Electric Manufacturing Vietnam using LabVIEW and SUBA Communication Hub. With the guidance of Ms. Phan Thị Thu Thủy, my team includes me, Lê Đỗ Tuấn Phúc, and my partner Vương Đạt Hưng, our sponsor Vinod Kumar, the Plant Director of Schneider Electric. Now I would like to begin the presentation. In this presentation, we want to talk about 5 main parts: introduction, introduce about the company overview and state of problem being faced, methodology, research and implementation, experiment and measurement after the system have been installed, achievement and future work, project improvement, the future improvement that can be applied. Schneider Electric Manufacturing Vietnam is a company specializing in the production of home electrical appliances such as switch, power sockets, which is divided into many different product lines to serve the characteristics of its domestic and foreign market. This is an overview of our production line. Next slide, please. This is an overview of our production line of Schneider company. The line have 5 working stations, including 4 assembly stations, 1 product packing station. In the current factory, we have 42 production lines with the same standard and size, served for 50 different product families for different markets. And our methodology start from facing the problem statement, provide the rationale, research previous project of the system, search for solution, set requirement, list metric, propose the specification of the system, building block diagram, layout, electric design, developing control application, implementation, experiment, and modify the final specification. Here the picture of the packing process. Here the picture of the packing process of most of the company's production lines today. Operator will take the finished product as well as the component accompanying product to carry out packaging. Since operator often follow their old habit while doing the process packaging, case of product shortage will occur. After complete packaging, they will put the finished product in the post and personally detect its quantity of them. When the product quantity is enough, they will process to save the label for the box. That's why in some case the box don't have enough products. And you can see here the two pictures compare the components in the packaging. The picture on the left side is packing with all the component includes, and the picture in the right side is the case of missing products. So I can show you quality defect statistic for the first 5 months of 2021. The whole factory have 171 cases of quality defect. This is the quality defect of packaging station with 50 cases of missing components, accounting for 29.3% the total number of defective case. And you can see that the Zensulo-A production line had the highest percentage of missing part in the whole factory. This is 50%. Besides problem of missing part, the time of operator to set up before production also need to be improved. The label are printed offline in the printing station. So before packing, worker will have to come there to check the label. And next slide. The average time for worker move from the production line to the label printing station is 10 minutes. And this 10 minutes is the non-value time. The company target want to reduce non-value time more than 50%. Next, this is a standard in statistic called failure mode and effect analysis, also known as FMEA, to evaluate the process. In FMEA standard, there is risk priority number scale to assess the severity of each error in process. So the RPN score is calculated using severity multiplied by occurrence multiplied by defection. And we have seen that the RPN score related to packing in ranks of 196 to 343 is larger than 125 points. This is the Schneider-Electric standard allowable score. So when it's reached that threshold, therefore an action must be taken to improve the score. So in the past, when so have several systems to solve the problem like chirL packing and traceability. Yeah, for the chirL packing, can control the weight of product. However, the system cannot show the offline label printing and cannot control the missing part. Moreover, the traceability packing is quite perfect. It can solve main problem in packing, change process to online label printing, and avoid missing part. But system cannot be useful when working with certain type of product families. The work will with part cost, and it will be useless when meet the order. So that's why my team's solution was to develop a packing software based on the LabVIEW platform to solving two companies' current problem. The first problem is missing part. For the advice of engineer in factory, my team used the packing sensor to guide the worker to the right process. Use the GOC scale to control the weight and quality of products inside the box. Second problem is the chain over time setup. We will use the Zebra ZK420T printer to automatically bring the label at the line, thereby reduce the time have to move to the printing station to get the label. And we have the input requirement for company. We want a Zensulo-A format production line, which for 210 growth code, packing station dimension standard with 1 meter length, 2 meter height, and 0.85 meter wide. The packaging process of each product and the database label of each packaged product. And then we have proposed the requirement for the system. The two main point missing part and chain over time should be avoided and reduced. Moreover, we want the system won't impact the capacity of product and easy to preventive maintenance. Based on those requirements, we build a system list metric, which are quality defect, setup time, coefficient impact, cycle time impact, preventive maintenance step, and preventive maintenance time. With time object will be measured direct by stopwatch, and the other parameters such as coefficient, the effective quantity will be checked from historical data, and there will be activity list to count the maintenance step. This is the proposed specification of my group with the criteria that are focused on quality defect missing part issues with edit value is 0 and the highest number acceptable missing part case is 3. Time setup application based on the target that the company have given. So the ideal time should be 5 minutes and the 8 minutes is the longest limit for product setup. Coefficient impact rate of effect from production performance is 0 or the most is 3%. Cycle time impact, the encapsulation cycle time will increase from 2 to 2.5 seconds in one cycle. And now my partner Hưng will introduce the rest presentation to you.
Thank you for your presentation. Hello everyone, I'm Hưng. I will continue the rest topic. Next, I want to show this is the log diagram. This is overall connection in that packaging application also interface for user was set up in the PC will be main run to communicate with another equipment such as SUPS communication hub via TCP/IP communicate and will the control the signal picking sensor via RJ45. The electronic scale chirL to control the weighting of products were connected with the PC via RS232. Last one, 3 linkers for individual label, inner label, outer label, connect via USB port. And next assembly layout based on packing station we're building before. My team will redesign the station packing to enable assembly on equipment. And electric design was designed following a standard of factory to ensure the safety. This is the 3D drawing electric cabinet. In the front view, has the indicator emergency stops with this connector. Inside have power supply 24 volt DC for SUPS communication hub and one circuit breaker. About the packing application, expectation of team will have a closely interface for user to operate. This is the logging interface. After logging successful, this is the main interface. Next, I will introduce process flow system. Operator with logging and input data reduction order. System log product data and start the rosette packing. The first operator will follow the rosette picking back by signal from sensor until enough the quantity back, then individual label automatic ring out. If enough the weighting and quantity the group box in the label group box, it will automatic ring out. If enough the quantity of group box in one outer box, the outer label will automatic ring out. This is the layout implementation before and after assembly. Electric implementation. And next is child run it as factory. After deploying and monitoring the system during the month of June, the export data quality defect, no any scale quality defect in the packing process. Conclusion, the system prevent the issue missing bag. The chain over time setup system of operator average 2 minutes and 44 seconds compared with the process manual average 10 minutes. The chain over time setup reduced around 7 minutes. Export data from Indosoft system of Schneider, compare coefficiency in the June to coefficiency in the May, so that the performance of the June is 77%, similar with the May is 73%. Conclusion, the system is not impact to the efficiency of production. The cycle time packing process is 9.5 seconds, increase around 2.5 seconds compared with manual process. The root cause in the step take the individual label from the printer setup as beginning time, set the speed green of printer is default 50 millimeter per second, leading operator waiting the label. So team already immediately set up the speed to increase 101 millimeter per second. This is the task list to maintain the system and time to each task. This is the final specification. The system has the defect rate can missing back, and the time to set up application is around 2 minutes and 45 seconds. The system not impact to core efficiency, and the cycle time will increase 2.5 seconds. And we have the preventive maintenance step. Preventive maintenance time is 45 minutes, and preventive maintenance step is 5 steps. And beside that, the system has the advanced function. It can monitoring the status process order. This is the application evaluated from the Schneider. It can reduce the high manufacturing defect rate and packing station and reduce the chain over time. And achievement of our project is conclusion. The system will achieve achievement expectation of factory and team that it can prevent the missing batch during the month of June. Besides that, decrease the chain over time setup around 62%. The second achievement in the failure mode and effect analysis, that is decrease the point risk priority number highest only 49. And the future work team already proposed the 5,000 USD for per station and already get the approval by land director, and target from now to end the year 2021, team will deployment the next 8 station and update. Until now, team already deploy successful 2 station in the last month. And beside that, the system have some points needs to be improved. The first, it combine the system with the traceability system, clean packing station with the tester to increase the efficiency quality. And next is the central database label server to increase the management. This is the application for release setter of data from factory. That's on my presentation. Thank you for your listening.
Cảm ơn phần báo cáo của em. Sau đây, thay mặt hội đồng, thầy xin đọc qua bản nhận xét của giáo viên phản biện. Đi vào ý kiến nhận xét. Về kết cấu cách thức trình bày đoạn án tốt nghiệp, đề tài có kết cấu hợp lý phù hợp với yêu cầu của đoạn án tốt nghiệp. Về nội dung đồ án, đề tài giải quyết một vấn đề cụ thể tại khu vực đóng gói của công ty Schneider Electric Manufacturing Việt Nam với mục tiêu: thứ nhất, giảm tỷ lệ lỗi do đóng gói thiếu chi tiết dựa trên phương pháp KHÓA trong Clean Manufacturing. Thứ hai, chuyển đổi phương thức in nhãn từ offline sang online để tích hợp vào trạm đóng gói bán tự động. Về kết quả đạt được: một quyển thuyết minh tính toán thiết kế, một trạm đóng gói bán tự động được vận hành bởi một công nhân đã được thử nghiệm tại công ty Schneider Electric. Những thiếu sót thì giáo viên phản biện không ghi ra. Về câu hỏi thì có 2 câu hỏi thầy đã gửi lên cái nhóm Zalo rồi, cũng xin đọc qua. Câu thứ nhất: if the factory deploy the current robot solution, its worker will handle on step from the initial component to the final finishing packaging box. A full package of equipment for a package for packing station includes one computer for picking sensor, one electric scale, 3 printer, and it costs about 5,000 euros according to the author's estimation. Compare with the solution of manual line packaging, in which the overall process is divided into substeps. Each substep is taken by a worker, and the whole process is arranged along a conveyor. According to the author, what is the difference between two approaches in investment cost and packaging productivity? And the second question is, as observed in the test clip at the packaging station, the worker had to stand to do all the task. Is it comfortable for him or her to work throughout their working shift? Rồi, mời em trình bày, mời em trả lời câu hỏi.
Can our team have 2 minutes for discuss?
Okay. I will answer the first question. In the question, the teacher asked me to compare with the solution manual line packaging in which the overall process to divide into the sub-step. So it's a sub-step by taking the worker. Because in the manual process, in daily operator will be take the step by step, and based on the action and movement of operator, they will configuration the sensor, and after operator to take the one component, the sensor it will trigger to next sensor, and we will step by step, and this is to instruction the operator work right process from method engineering demand. Okay, that is my answer for question 1.
Okay, and I will answer the second question. So for our second question, yes, as that observed in the test clip and backing station, worker have to stand to do all the tasks. is it comfortable to him or her to work through their own shift? So first I will tell the reason why he and her have to work through the shift, because this is the staffing arranged from the process engineer in company, and the packing position has just one worker. So that's why they will work through that position or work through the shift. However, yes, they do not feel comfortable when they begin to do the process because it's not the same with their habit. But however, the habit can be changed. That's why from the beginning time, some issue case have been issue case that means they make wrong the process and they take the effect to the performance in production. However, the habit can be changed. So at the lay after applying the system, the performing have been not become to normal, and they feel no more uncomfortable again because the habit have been changed. So the most mean of this process that will change the habit of the worker for they to force them to do the right process. Yeah, that's the second answer of my question. Is there any question from the?
So I have some comment and question for you guys. This is a real project. So I highly appreciate that you applied the study knowledge to deal with the real problem to in manufacturing. But I have one question. So my concern is the same with the previous question. This is productivities. If there's any feedback from the factory about the productivity, the improvement of productivity or not? Okay, you can answer.
Okay, for the productivity, I will the manufacturing they just demand the fact that our system not impact to the core efficiency of the production line. And after experiment to the export data from the system of Schneider and compare with the previous month, and the core efficiency of our system and previous is similar. It means conclusion that our system is not impact to efficiency of the production. That's my answer.
Okay, thank you.
Okay, I have one question. How to make sure that the worker didn't make any mistake? How you make sure that the worker didn't make any mistake? Because the mistake caused not by the, I think not by the indicator, right? Indicator can have a little bit, but normally the mistake is caused by the fatigue. The worker become tired and not very alert. So how can you? What is the function of the system in order to reduce the fatigue or reduce the fatigue of the worker?
Okay, let me show you the workflow first.
I already seen the flow. I saw the green indicator, right? The green indicator is like some indicator to have the worker didn't need to memory the step, right? But I think after few days of working, then the worker will become familiar with the system.
Yeah, but personally, we are still human and we are still person. So if you not force them to the habit, not force their habit, they will be in some day they still will be again. And this is the very important issue because it is the quality issue. You know that the missing part and the missing issue is the very with the occurrence level is the seven level. It's just below the level 9. So in this company, this is the very important level. So they don't want this issue occurs anytime again. So that's why we need to make this system. And for your first question, that how to make sure that they not do the wrong process. So the sensor, this is based on the sensor. So the sensor will defect. We will set the process first for each of production families, and the sensor will have the ring line, red line. It also have the detect in the bottom. So when the action have been done, the sensor will detect this activity, this action, and send to the database. That's okay. This action have been done. So next action, this action is the final action of the process, and it will bring the individual label or inner box label or outer box label. So if they do the wrong thing, the label will not bring out, and they cannot do the packing process. And this will be affect to the production performance. However, change the harvest and the speed have been speed up. Yeah, that's my answer.
Okay, thank you. So with your system, the KE tracking code efficiency increased by 4%, right?
You mean
from 73 to 77?
No. The KE the KE of each production line will have the target. The specification in the system is just not impact. And when the compare between the reverse and after deploy the system, the core efficiency is not so that it not impact to the efficiency of production line, because based on man will have the KE different. It will belong to the demand and forecast of the production line that will run in this month. Yes.
Okay, and also the cycle time increased for 3 seconds, right?
Yes.
Is that too much?
Okay. The point in here I already sharing in the experiment, because my team has already at the beginning. My team already set up the speed up of printer. The speed up of printer to bring out the label. It just only 50 millimeter per second. It's too low because it will leading to operator when they picking done back, and they were must waiting the label to ring out.
Okay.
So immediately my team already to set up the speed up increase, and the issue now already improved.
So it's improved, but there still be gap time between picking the label and the part, right?
Yeah.
Still the gap.
The gap in here. This is the speed. The speed of the printer is green.
So okay, the workers still have to wait for the label to print.
Yeah. So I already increased the speed of a printer. Is increase the velocity, the speed.
Because as the Professor Duck is saying, I think after a few days of working, they will be familiar with the whole thing. I mean, because this task is so simple, and it's not a complicated task, man. I mean, if it has like a lot of steps to do, then maybe this system can be used to train the new worker. But I don't know if it will bring any improvement to the whole process.
Can I, sorry for interrupt, can I add more some information? So for this symbol, sorry, yes, this symbol, but if you say that the workload not that huge, that's wrong. Let's say before the Zenslow A format had 200, we sold for 210 products in one family. And did you know that this in the production line, not just one day and do the same process in each day, the process can be changed. and operator need to do this process again. So the habit can be changed, right? And you know that if I do it if I make this system to do it 1 to 2 days to force the habit for this process, but if I remove it and let them do it by their nature, in some days, no, I bet that in some days, not just some days, just 1 week more, the issue of quality will occur again, because the process in this workstation have been changed every day or every shift, because not just we will not just make that product in the station, also the other product, and it's in the limit of 210 products. Yeah.
Okay, it makes sense when you use one machine for different products, and because if it is just for one product, I don't see the improvement here.
Yeah, this is for one packing station. Yeah, not
okay.
umbrella. Yeah.
Okay, thank you very much.
Yeah, thank you.
Các thầy, các quý thầy có góp ý chỉnh sửa gì cái đề tài này không nhỉ?
The first thing that you need to check in the format of the report, especially the references. Okay. There may be some typo in the references, so you need to check, double check. Okay. Then is there any the drawing, the technical drawing? Because what I saw here is only drawing of the workstation, no more drawing, right? And the workstation is not done by your group. It's done by the company, right?
Yeah, it's a stand-up company, and we redesign.
So you have no technical drawing in this project?
Mostly we use the voice, the assemble voice. So we're not too much technical drawing. However, if you want me to add more, I will add in the drawing of the hub, connection of electric hub, or
I think at least you need the electrical drawing to how you set up the whole system, the indicator lights, the printer, and also the power or something. At least you need that drawing, because here I didn't see anything. So.
Yeah, we will re-adding it. Thank you for your advice.
Okay, I think we can move to the final project. Right?
Okay, so we will go to the final one. Tên đề tài cuối cùng của hội đồng sẽ có tên là Design and Build Up Automatic Bed Bottle Supply System. Sinh viên thực hiện gồm có 2 sinh viên. Sinh viên thứ nhất Nguyễn Công Minh, mã số sinh viên 161463037. Sinh viên thứ hai Hồ Duy Trung 161460053. Sinh viên hướng dẫn thầy thạc sĩ Tưởng Phú Thọ. Mời các em báo cáo.
Good noon, everyone. We are Group 6, and our project is Design and Build of Automatic Pet Bottle Supply System. I am Nguyễn Công Minh, and my partner is Hồ Duy Trung. Our advisor is Mr. Tưởng Phước Thọ. So in our project, we have separated it in 4 sections. The first one is overview of the project. The research is about the cost saving of the environmental system and labor saving force. So plastic recycling has always been one of the top priorities in protecting and preserving the environment. There are a lot of places and areas that lack proper recycling system. This led to the destruction of its surrounding environment. Even if there is the labor force required for that job, it's just too much and inconvenient. So we wanted to come up with a solution to not only save time, but also to reduce the human labor, as well as remodel the entire pet bottle distribution system to a newer, modernized, and convenient one. So this is the pet bottle. Our pet bottle is the one we use is 20 centimeters in height and 6 centimeters in diameter. PET or PET stands for polyethylene terephthalate. This is our general form of containing water. It is very much used everywhere and can be seen in any stores you can buy because it is strong, it's very convenient, and it's easily used. Our objectives when making the machine is it has to be light, simple, and easy to replace. It also has to be fit in area that needs those don't have factories or proper plastic recycle station. The second section is design and implementation. This is the overview of our machine. A part of it is called the scrambler. We'll talk about it later. It's a part that we need to use in order to flip the bottle in the correct position. It includes a small motor, a flipper, which is a V-shaped device that can catch the neck of the bottle, and a funnel that catch the bottle that is pulled down to the final platform, as you can see. And this is our components right here. The first one is the bowl to contain all the bottles, and the small part of it is the exit tunnel. The second one is the spinning disc. It is placed directly under the spin bowl. This can scramble and push the bottle around so they can exit through the tunnel. The third one is the connection between the exit tunnel, and that small part right there is the flipper. The third, the fourth, and the fifth one is just the connection part of the motor to the shaft that spin the rotating disc. And next we have our motor. The seventh one is the funnel and the flipper, the V-shaped device you see right there. And three other parts are respectively the Hmi monitor, the electrical cabinet, and the electric blower. This is our total view of the entire machine. This is how our machine works. The bottles here are very hard to push because they don't have anything to kick them around to create more force. So we added a secondary motor for the first one. The secondary motor can be used like this. Sorry for the quality of video though. This is just our demo video because we cannot use our machine after the lockdown. So and next, the bottles will be soft thanks to the gravity, so it won't always land on its bottom. So we have to create something that it can always land on its bottom, and this is called the flipper. As you can see in the video, we use the V-shaped flipper to catch the neck of the bottle, but it cannot catch the bottom part of the bottle. We have total of 4 situations. Those we use them. We use the name of the part that reach the flipper first to call the name. For example, the first situation is the head-tail situation. This is when the head of the first bottle reach the flipper first, and the bottom part of the second bottle reach the flipper later. As you can see, the first one is caught by the flipper and it changed the position of the bottle so it can land on the bottom part. The second situation is the tail head situation. The bottom part of the first bottle is too large, so the flipper cannot catch it, and it just falls naturally in the bottom part. The third one is the tail situation. It is the exact same of the second situation. And here is the tricky part, the head situation. Because our bottles that we use as samples in our project has a very deep bottom part, and its head is very small. So the head of the second bottle, we mostly stuck in the bottom part of the first bottle. As you can see, it's stuck right there. Push the head of the second bottle down, and its bottom fall upward, making the third one or the fourth one in the train get stuck. So we come up with a solution. We have to come up with a solution that eliminates the head-head situation and also have to keep the other situation intact. Otherwise, we have to scrap it all over. So we added a bummer and reduce the motor speed. The bottom part of the first bottle you see, is slip down, and then the second bottle can push it on the edge of the second head of the machine, and then it can be catched by the flipper later. This is our electrical and control design. We use the PLC S7-1200 to operate our machine. And this is our operation flowchart. The machine is operated by putting the bottle on the top, and it scrambles through the scrambler and then exit out. After a few seconds, if the sensor not detect the bottles, it will stop the machine. If it's not, the exit blower will blow the bottle to the next train. This is our Hmi Monitor Interface. The first one is the user interface. We have the auto and the manual interface. The auto one we only have run and stop. We push run and every component in the machine will operate. We could push stop to shut down the machine. For the manual, we have 3 separate components. That is the main motor and the secondary motor and the fan. Each can be opened and closed separately. My partner Trân will continue our presentation. Thank you.
My name is Trân and I will continue our presentation right here. So we're coming to the third section right here about the experiment and analysis. So before we upgrade our system, there are errors that occur at the main part of the machine. So for each error, we have come up with our all different solution, and here are the first one. Before we are upgrading our machine, we have been running it first, and the situation like you have seen in the video before, that the bottle gets stuck without the motor and the propeller for the pushing from the propeller to make the space enough for the bottle for not getting stuck. So that after that we adding some this, and like you can see in the video, it's come out fluently to the tunnel. And for the outside of the boat, the bottle will mostly stuck at the flipper when a head situation occurs. We already stated this in the previous section. So with the solution that we have added the bumper over here. And later, when working on the tunnel, we install one more bumper in the middle of the tunnel to further eliminate head stuff and control our bottle output speed at better rate. And here are our experiment tests. First is this is the surface smoothness test, which are the purpose to test the interaction surface between the PET bottles and the machine operation surface to acknowledge the falling pace of PET bottles as it is to a container. We have tested it 10 times in total and with the quantity of 30 bottles and only 80 bottles stuck. Next one is the flipper efficiency. We have tested in 4 different situations and only the head situation had only the 50% success rate and other 3 are 100% success rate. Come up to the electric blower test with the wind consumption level below 70%. It cannot have enough force to push the bottle to the line. And here is our analysis final. With the addition of the bumper over here, so which get rid of a situation where 2 bottles get stuck at each other, we get roughly 83% success rate. And the motor, when we add the motor to and this bumper over here to counter the event when the bottles are locked together inside the bowl or stuck at the entrance of the exit tunnel. These 2 factors have pushed our overall success rate to roughly 96.3% success. And here are our final section about the conclusion and the further research. We have encountered a lot of difficulty during the process of our building the scrambler and the electric wiring. So however, with the input requirements and go through the implementation process, the research team has achieved this following achievement. First of all, it's about a theoretical research. We have understanding of the operation principle, control principle, and theory of DC motor with encoder controlling sensor detective, PLC configuration, inverter function, and motor controlling. So the second achievement, we have about the mechanical design. Our design is specialized design on the SolidWorks and disassembling and as well as assembling mechanical part of the machine. The model ensures the technical and aesthetic requirement. The third achievement is the electrical design that we can make sure the model ensures the technical and aesthetic requirement. Our final achievement is control design that we can form controllable system which Hmi monitor throughout the PLC customized controlling. And in the future, for the further research, with our PET bottle distribution system, we think that we could make a design that can be further improved to fit more in more areas, not only in the local rural area, but maybe more in other better developed areas. So the design can be made smaller, much more compact, and the scrambler is also reduced, giving more space for more processes can be added after the electric blower step. But at the same time, it should be more precise and can operate faster. We can also improve our component gradually one by one with more carefully chosen appropriate components. And final further research is our strategy vision is to create a PET bottle distribution system automatically with no human touch due to the industrial right now. Thank you for listening.
Phần báo cáo của các em, thay mặt hội đồng thầy xin đọc qua cái phần evaluation của giáo viên phản biện nha. Thì evaluation first content and workload of the project. There are 5 chapters, references, and appended. Trends. Second one is trends. Apply knowledge in mechanical design, electronic design, and PLC programming to solve real problem. An automatic back bottle supply system in design and manufacture. the experiment results indicated the system worked well. Witnesses, the mechanical design is not optimal and should be optimized. The program of PLC is rather simple and should be improved. The design and real products do not meet, and approved for oral defense approved, and overall evaluation good. Giáo viên phản biện thì không có cho câu hỏi nhé. Xin mời quý thầy trong hội đồng có câu hỏi ạ.
I want to ask, why did you use PLC for this application? This application is quite simple. It doesn't need a PLC or anything. It's just a simple electrical circuits can do the whole thing. Why did you use PLC?
Because we want to improve the process by controlling on the screen on the HMI, so that we are using PLC to easily connect to the HMI and control it without touching or that is my point of view for not using the PLC here.
This application is quite simple, man. I don't know, what's your contribution to the project? Because as I know, this system has already developed in the previous project. I mean, the previous year.
Yeah, we know, because it is our senior project. We just like scrap it on, like we uninstall everything and do it over. We just upgrade it to a more like optimal design and structure using the old. Yeah.
Okay. So you rebuild the whole system.
Yeah.
From the mechanical to the electrical.
Yeah. No, not really, but we use the own frame and own design.
So, and did you cite it into your project? Did you mention that the previous, your senior did that before on,
no,
on
we
your
didn't.
project? Oh, okay.
Because this one, the most option for optimal the process, we have only doing it mechanical by ourselves, and just only the basic thing like the frame to make the construction building up, that using the previous one. And like we have been mentioned in our presentation about, we are designing the system called Scrambler, and it consists of the ball inside the motor, the HMI, and we can also redesign a little bit of the electrical design for that. The previous one didn't have that because the design of that structure is very complex and very heavy. So we have been eliminate that and replaced with our new one that called is Scrambler.
Okay. And did the successful rate improve?
Yes, sir. The successful rate of the old one when we first tried it is like less than 10%. It's really, really low.
Okay, so the most which step that affect the successful rate the most?
Yeah, definitely the Scrambler. Definitely.
The Scrambler on top.
The Scrambler is our. This is the name we call it for our entire scrambling system. Is the one with the tunnel and the flipper that catch the bottles.
Okay, and I also see that the blower also take into account, because the successful rate is the blower.
No,
the
electrical
blower.
The blower always has the 100% success rate as long as the model land.
Okay, why I see some decrease in the percentage in the report for using the blower.
You mean the chart, the table that we make, right?
Any question from the committee?
Okay, I have a question. Actually, in this system, we can buy easily in the store on the company. That's the best bottle origin patent. That's the full name of the system. So in your report, I think you can improve about a mechanical design or controller. No problem. About the controller, I have no question. But about the mechanical design, I have a question. Which factor influence on the productivity of your system? You said that you can improve about 10%. I don't understand which factor of 10%, because this system is the most important of this system is productivity, and which factor will influence on productivity?
Yeah, so we can always improve our process in the bummer part, because we only said in our presentation that the bummer part is like our last resort to the project. The bottles always like when head situation is stuck, right? So the bottles we only have a very few solutions for that, because the tunnel and the whole scrambler system is like very simple and intact system. It's small, so we cannot change a lot of it. And when two bottles plug at each other, like we have to, if we want to change something, we have to change the entire system. So we have to create something that's small, very small, and it also have to eliminate the head situation and also keep the other situation in the same way. The bottles that we use at the samples in our project is like is very random, and it has a deep part of the bottom and a very small head, so it gets stuck very easily. Like I have right here is it's a Hmi bottle. It is a very standard bottle for Vietnam Airlines company, so you know it is standard, right? It has very shallow bottom part, very shallow, and a big head, so it can slip right through very easily. Our bottles are not like that. It's stuck very openly, so we have to create something small, and we have a few solutions. If you ask, I can name them all, but I don't think we have time for that. Our bummer actually is one of the few first solution, but it's as we said, that is reduce our motor speed in order to, because the first one have to be slow, right? It's slow, so it slip down the bummer and move on. So we have to reduce our original motor speed for like 20 or like 30%. That's 30% loss of efficiency in a machine. If we can improve that, our machine can be speed can be pushed like 20-25 more speed, like something like that. So efficiency will always be increased.
Okay, thank you very much for your answers. Actually, I cannot access your report. So could you show us the technical drawing of the part you developed in this project?
Yes, I will show you. And here our sample drawing for that for our project. As you can see right here. This is our bowl design, and this is the frame of our machine. This is our scrambler, the output with the flipper and the tunnel. And that's all. Is it okay?
Can you show again? Can you show again? I just asked, what is the most important development in this project which your team developed? Please explain carefully what is, just explain what is the most important development by the drawing, by the technical drawing.
And you mean that I have to show you the drawing that we have developed?
Yes. Yeah, you just show and very quickly I cannot see exactly what part you designed to improve the productivity of the machines.
Because your team said that this system already made or built by the previous member, and right now you have to improve something, and which important thing you improve in this project.
So it means that finally, which part you are working on this projects, which one is existing before? Do you understand what I mean?
Okay.
Okay.
I'll show you then. This part is the previous one with the bowl right, with the disc right here and the motor right there. The frame also too, but the HMI and the electrical cabinet we have to redesign again. Also, the most important thing is this one is our redesign for the more compact and easier, effective way for the boiler to get outside. The previous one will be bigger and it's like the way to get from the boat to come outside is can be triple the way from our design right here. This design is reduce the more distance and easier for the bottle to go out. So this is what we are working more on a lot on this. So you can see the design here. It's just a simple design, but it makes the process operating different way from the previous one.
Okay, I think you can you evaluate by yourself how many % you work on these subjects in these projects?
We have worked like where we design the frame too, because the first one is have to be higher for the distance from the boat to go outside. So we have to cut it on and restruct it, the frame over here, and we design the electrical design over here to adding the HMI for the control system. Also, we have to recalculate the force from this motor and the force of this. We have to recalculate that in order to able to be in our new design over here.
Okay. Okay.
Yeah.
Okay.
Dạ hay Đức có ý kiến gì không thầy Đức?
Không, mình không có ý kiến gì hết.
Rồi, vậy theo chắc mình xin phép chắc kết thúc và các bạn vào waiting room rồi chờ hội đồng thảo luận, rồi sau đó các bạn ra lại để nghe thông báo, nghe công bố nha thầy nhé. Một số cái